Welcome, hello, and welcome to my talk on the topic of infrastructure as code on AWS, a deep dive, right? So I will be covering some finer aspects of infrastructure as code on AWS, but I'll get to the details a bit later on, but it's going to be focused on a bit more deep dive. So I'll probably go a bit more technical. You'll see some code in the demo, and yeah, feel free afterwards to kind of ask me questions, ask both Sergey and myself some questions on this topic as well. So let's kick it off. Now, as I mentioned, this is going to be a session 300. So at AWS, we like to give session levels numbers, right? So session 300 literally means an advanced session. So I will not be talking about a couple of things. I will not be talking about infrastructure as click. So I will be avoiding a lot of clicking. I don't want to explain what is AWS. I don't want to explain why you should use a cloud. This should all be pretty much out there. I will not be telling you why should you use infrastructure as code. I really hope that you're already using it, no matter what you're using. I just hope you're using it. I will not be telling you how to do infrastructure as code, at least not the basics. I will not be telling you how to do it. I'll explain a bit more, a slightly more advanced topics when it comes to IAC. And last but not least, I will definitely not compare various IAC tools out there. So with a slightly, maybe just a bit, right? Not all of them. But before I continue, you may be asking yourself, who is this bald person and why is he talking to me? So my name is Darko Meszaros. I am, as you were told initially, I'm a developer advocate or a technical evangelist, how they call them, at AWS. I have been working for AWS for the past 4.5 years now already. So I started back in premium support, move on to solution architecture, just like Sergey. And now I'm a developer advocate, or basically my job is to talk to you developers, get your feedback on things, at the same time try to teach you something and you also teach me so we can improve the service together. I originally come from Serbia, so hence the Cyrillic type lettering and all that stuff. So yeah, I can understand Russian a bit, I guess. I can read at least. And I've been, and feel free to follow me on all the social media as you see there. I post a lot of things. I do videos, I do streaming. So very happy to help out more people. But let's all move on. So what we will talk about then, if we will not be talking about what and why and those things. Well, so let's talk about a person. So this will be a story about a person. And this person is an engineer, right? So how can we make this engineer's life better? This is a person who is tasked to build global, scalable, secure, all of those little things, cloud infrastructure. And how can we make that person's life better? Because we all, on a day-to-day basis, strive just to make our day so much better. Whether that be a bit more challenging in a good way, whether that be we learn something new, or we automate the boring things. So how can we do these things? But before I continue on that exact topic, let's step back in time. So long gone are times where you used to do racking and stacking. So as you see from this lovely picture, of servers or desktop PCs acting like servers, when you used to provision a server, you would have to actually plug in a cable. You would have to stack something in a rack, right? I used to do this a long time ago when I used to work for one of the other companies. I was something that was called a server provisioning administrator, right? So my job was to install operating systems on physical boxes, right? So they would tell me, hey, Darko, here you have 500 servers in Fairbanks, Alaska, install Red Hat on them, right? And I would do it all through the lovely, you mount an ISO on this, I don't even remember what was the name of that lovely Java remote administration utility. You mount an ISO and then you hopefully install something, and you have to go through all of that console. Nothing's automated. It's slow, right? So a long time ago, we used to plug cables. We used to install operating systems. So we used to do things like this, right? So we used to plug stuff into routers and plug stuff into boards. But we get somebody else to do that for us, right? Let's have somebody else do that. So let's use the cloud. So how does the provisioning in the cloud look today? Well, it looks a lot more like this. So there's a lot more code and a lot less cables, a lot less racking and stacking. So we have replaced racking and stacking. We have replaced screwdrivers with text editors. We have replaced cables with functions, right, or something like that. So we have much more of this now. Now, this is not easy, but it makes our lives easier. But how can we get this even better? So infrastructure today, or infrastructure, is just a piece of code, right? So, and this piece of code, as you can see in this example, this is a CloudFormation example, and I'll get to what CloudFormation is, about the provisions. What is this provision? Provisions a code commit repository and a Cloud9 environment. So super simple. This is nothing special. This is not something that should be new to you. This should be the baseline. No matter what you do on the cloud, no matter which cloud provider, no matter which framework you use, you should use it. So we use code like this to provision our infrastructure. Why? To make it easier, to make it repeatable, to make it more visible what we do, and it eases troubleshooting on what we have done and how can we fix it, right? But code in itself like this, it's fine, it works, but there are some things that we can do much, much better. And what are those things? What can we do here? Well, first things first, because this is code, why not treat it like code? If we treat things as code, what do you do with it? You take it to a pipeline, right? So you apply all the best practices when it comes to software delivery. So from version control, where you can commit your infrastructure code to a Git repository and version control it, to running some tests, right? Running unit tests, running local syntax checkers, having people look at your code, having a second pair of eyes, seeing what you do, having an actual production integration testing, deploying it to a staging environment or a testing environment, and then finally safely deploy to production. Again, everything like we would do with normal software, we just do now with infrastructure software, because it makes our lives easier. Because if you make a mistake, you can quite early on catch it. So how does this actually look? How does this workflow look? I mean, it's pretty straightforward, but you should be able to see, you should be able to have your architects, your engineers, your DevOps engineers, right? Write your infrastructure, write the code, commit it to a repository, put it in GitHub, Bitbucket, code commit, whatever, right? Put it there, have it under version control. That code should be, in essence, tested through a pipeline. Now, how are you going to test your code? Depends which framework you're using, but you should definitely be doing that. From static checks, such as lint testing and just basically checking the syntax against some spec, to actual full-blown tests that you deploy to a staging environment and just, well, hope it works. And then finally, the deployment to production should be actually across multiple regions, multiple accounts, a lot of things. So that's how it kind of works. But one of the most important thing here is this repeat pattern of it. Now, coming back to my old story about when I used to provision, cables and servers, you would provision a server and just hope it works, right? And then the next time you provision a server, you would most likely do it differently because some time has passed. But here, you get to learn from your mistakes and from what you did really good immediately. So you get this immediate feedback loop of what's been good, what's been bad, and keep on repeating. Repeat your process until you do things better. So by applying this, it gives you the ability to kind of streamline or perfect your infrastructure deployment that much better. So let's talk about the big boy here in the room when it comes to AWS. Let's talk about CloudFormation. I'm going to be talking about delivery of CloudFormation. But before I begin on the more complex topics, I just want to give a quick, short talk, intro, whatnot. What is CloudFormation? So CloudFormation, I know I promised I'm not going to talk about the basics, but I just want to make sure I get a really nice, solid start. So CloudFormation is a service or is a framework that takes your code. Basically, it's a common JSON/YAML language interpreter, or a markup language interpreter that converts JSON and YAML code to actual resources on AWS. So think of it as a way that you write your resources, such as EC2 instances, S3 buckets, VPCs, whatnot, right? You write them in this YAML or JSON code, you write their configurations, you pass it on to CloudFormation, then CloudFormation handles the rest. It takes that and creates all the resources in things called stacks, right? So stacks contain resources that you create from this code. So here's a great sample of that code. This code you have actually seen earlier when I had that first slide of code or second slide of code. you write code into, well, templates. Well, right, there you go. You create a stack from that template, and within that stack, you have resources. Now, when it comes to resources, CloudFormation currently supports over 430 resources, but that's actually expanded now to much more, and I'll come that later on to when I talk about some other things. And also, CloudFormation handles dependencies for you. So, for example, you create EC2 instance and a VPC, but that EC2 instance sits in that VPC. So CloudFormation is automatically able to detect that that instance actually depends on that VPC, so it will wait for that to be handled. But also, you can also manage your own dependencies. For example, if you have two EC2 instances that depend on each other because something is configured on one that the other one needs, you can manually define that this one depends on that other one, right? So currently, you can write things in both YAML and JSON. When I started, it was only JSON. It was horrible. So if you are getting started with CloudFormation, please do use YAML. It's easier. At least you can make code comments on it much more easier. But let's move on to some more advanced aspects of CloudFormation. Let's talk about best practices, or at least some of the best practices. And the best practices start in your editor, in your code editor, because where do you start provisioning infrastructure as code? You start in your editor. Which one should you use? Use the best one. Which is the best one? I wouldn't go there, but let's say Vim. So use the best editor. Use the editor which has all the plugins that you need. Now, there's a bunch of plugins and tools that you can kind of use with CloudFormation to make your life easier. The example you see here on screen, here somewhere, I have a problem here. Yes, you see here on screen is using CFN-NAG, and CFN-NAG is showing here, hey, you have some potential security problems on your template, or this will not work, or those kind of things. So in this, I used VS Code here because there's a really nice plugin for CFN, lint, and NAG, which I'll get to, and it kind of shows you here. So the easiest way to start is to just use an editor that has all of these things built in. So it will make your life much, much more easier. There's other tools that can basically, with a couple of keystrokes, just generate the entire skeleton you need for your CloudFormation template and do it all straight from the editor. Now, the example I've showed you before, the tool, the warnings, you've seen the plugin. Now, it's not just a plugin; it's actually a command line utility called CFN-NAG. It's from Stelligent, and you can install it by running gem install CFN_NAG -- user. And this tool, in essence, detects patterns of insecure infrastructure. So it understands certain things in your template that are potentially insecure. So by running this as a plugin, or actually running it as a command line utility, which you can just run from your workstation. So basically, it will give you the ability to kind of check your template against some rules, but you can also create your own rules. You can create your own specific rules. What do you consider to be secure infrastructure versus what is not? So basically, you write your template or have multiple templates. You can just execute this command, and it will show you some output. In the example you see here, you see that I have a failure, F2, that my instance role, I'm actually creating an instance role in this template, and it's failing because I am allowing action all or star, and that's insecure, right? You should never do that. But it's also throwing me like true warnings that I'm actually opening up my AWS security group, my VPC security groups, to some larger network subnet, which is not /32. So it's potentially insecure, but it's just a warning. So this is great. It's a really lovely tool that just runs on your command line. Perfect. And also there's a plugin for that. Second tool, and this one I cannot talk enough about, is CFN-Lint. CFN-Lint is it's a code linter. It's a code linter for CloudFormation templates. So what it does, it can lint your CloudFormation template code. It's basically a static checker of your code. It just makes sure that the code that you've written actually does work. It will actually check it against the CloudFormation spec. So it will look through your code and check it against the CloudFormation spec to see, is that okay or not? And what it also can do, you can test your code through different regions, because it's important. Some things are available in one region, some other are not. So it's also, I'll show you actually a screenshot later on how that looks, and it can also be kind of configured directly from the CloudFormation template. So if you write your CloudFormation template and you have your metadata section, on the metadata section you can actually add some certain things, like you can skip specific checks or whatnot within CFN lint. And to install it again, it's just pip3 install cfn -lint -- user. So it's again a really neat command line utility that works really great. And this is actually how it looks. So I'm not sure how tiny this is on the screen, but hopefully it's okay. So you see me running CFN lint on the exact same template. I'm actually running it twice, but in 2 different regions. So this template I'm actually creating on I think a single EC2 instance and a VPC or something like that. Yeah. So in the first template, on the first CFN lint run, I basically get a couple of warnings that I'm hard coding availability zones for my autoscaling groups. Yes, autoscaling groups, right? And that's just a warning. But on the second one, I am specifying, hey, -- region EU North, and it's failing. But it's failing because EU North does not support T2 micro instances. T3 and above are the only ones supported. So it's a really neat way to kind of get that error immediately on my console instead of me going, the web UI and clicking a bunch of buttons, uploading a template, and maybe it works, maybe it doesn't. So it's a really neat way to do it. And this is kind of my tool of choice when I do CloudFormation template development. So, you write the change, just make sure it works right there and then. But so both CFN lint and CFN nag are great tools, right? But they're static checkers. So they do check against, the spec, and they do some things like checking, is this secure or not? But they can just do that. They cannot check if you have limits or not. They cannot check if you have the bucket with the exact same name created already or something like that. So for those tests, you actually need to deploy your template to see will that work. Now, you can do that. You can try it out. You can deploy it, see if it fails, and yeah. But there's a tool for that. There's actually a tool developed by the folks at AWS that will help you test your CloudFormation template by deploying it. The tool in question is actually called Taskcat. So Taskcat is a service, that's not a service, a tool. It's a command line utility tool that deploys your CloudFormation templates across multiple regions with multiple different parameter sets. It supports CFN nag out of the box for linting, so it will actually run CFN nag before it tries to deploy your template just to make sure it's fine. You can deploy, again, as I said, to multiple regions with different parameters, and it really generates a nice report once it's done. So you kind of run it against one or multiple templates, and it will deploy your template across multiple regions with different parameter sets. You can define some tests in it, right? You can kind of have those different tests defined there, and you will have the information: is it available or not? Is it working or not? So to install it, again, it's just a pip tool. Well, pip3 install Taskcat, and that should work. And when you use it, it actually looks something like this. So the thing you see here is you see a test. Basically, it's a Taskcat YAML file that defines the project and the tests. And the different tests it runs here, it's actually deploying things in different regions. And it is taking different parameters. For example, I am deploying the same template into US West 2 and EU North 1. Because of the differences between the regions, I need to define that the T2 micro is for US West 2 and T3 micro is for EU North 1, also AMIs and whatnot, right? So, and this will basically launch these templates with these parameter sets in these regions, and it will terminate them immediately. So it creates those stacks, makes sure or attempts to see will they launch or not, and if they do, it's fine. It terminates it. It generates a lovely little report, and I'll actually show this how it looks. So this is how, again, I hope this is not too tiny, but it shows Taskcat tests run against basically all the CloudFormation templates locally, or the ones defined in Taskcat YAML, and it's creating 2 CloudFormation templates in EU North 1 and US West 2. So it will create those. It goes through the standard CloudFormation create progress. It will show you all of those things, and at the end, it generates an HTML file locally that basically has your your report, is it successful or not? And you can actually view the logs, all the CloudFormation logs then and there from your command line, basically. So it's really great to kind of have it all there on your workstation, so you don't have to rely on clicking a whole bunch of times on a CloudFormation web page, because in essence, sometimes, especially in production environments, you might not have access to those things. So using things such as this will help you a lot in the long run. Now, I talked about CFNAG, CFNLint, Taskcat. They're great tools. They work amazingly on the command line, but that's not their place. So there's a better place for them rather than just the command line. So where do they belong? Well, I mentioned this before. They should sit in a pipeline, right? They need to be in CI/CD, right? So basically, this is how like an ideal CloudFormation pipeline, CI/CD pipeline should look like, where you have all of these different tools, both CFNAG and CFNLint and Taskcat, sitting in different stages of the pipeline. So you can see here what's happening is that your developers are pushing your templates to a code commit repository or GitHub or whatnot. It's being picked up by Code Pipeline, which is the CI/CD tool that kind of orchestrates all the parts of that. Now, in the build phase, or the early test/syntax phase, we have CFNLint and CFNAG actually running those static tests. Then in the test part, you can use Lambda to kind of trigger Taskcat to invoke the creation of the stack in a testing account or just somewhere else. And then once all of that is fine, you can kind of come back to your pipeline to, hey, so that was successful. Let's continue and let's promote these changes to a production stack. Let's talk about some best practices, right? So I'm going to talk about some additional best practices when it comes to CloudFormation, but they're not all just CloudFormation. Some of them are also like infrastructure as code in general. So let's start with number one. Layer your applications. You should definitely layer your applications even when it comes to infrastructure. Do not put all of your eggs in one basket. So do not put all of the resources, everything you have in a single template. A, templates have a size limit. B, it's much more difficult to debug. So you can kind of layer it into different stacks, some things for static content, some things for example, security, front end, back end. Your data layer needs to be completely separate. So do not put your data layer together with your other layers, because you don't want to delete the CloudFormation stack that hosts your database, right? Because you wanted to delete a front end server or something like that. Just make sure you layer these things, because even if something happens to one, it only happened to that one. So it's much more easier to kind of work with and troubleshoot. And again, having multiple different isolated environments makes this much more easier, right? So absolutely. Best practice number two, use resource imports. Your resource imports are great when you want to do stack refactoring. So what is a resource import? You can basically, so in the past, and I used to work in support, and this was a common problem. You create something like a database, right, in CloudFormation. Then you decided, I want to move my database to a different stack because I don't like the stack name, or I don't something, right? So what do? Well, in the past, you didn't do anything. You would just kind of leave it. But now with stack imports, you can basically import that resource in a different stack and delete the old one, and it will stay in the new one. So resource imports are great to kind of do some additional stack refactoring when it happens, when you want to do it. So that's really cool. You can also use resource import to kind of fix drift. And what is drift? Well, drift and drift detection in itself is the ability to kind of detect if a change has happened outside of CloudFormation. So let's say I have an EC2 instance and I have created it using CloudFormation, then somebody has went in and just added a public IP address to that instance manually through the console. Ooh. So drift detection can actually detect those changes and say, hey, you know what? This is different. This is not how it should be. And this is a drift has been detected. Now, you can go and revert that drift. You can change it back, or you can again use resource imports to fix that drift, right? So by fixing, I mean accepting it, right? So you can re-import that resource with that change, and that change will be applied to the CloudFormation template again. And finally, when it comes to best practices, and this is very important. So use parameters and use mappings. So to make your template as much as let's say agnostic as possible using parameters and mappings. You can much more easily use it across multiple regions and multiple accounts and whatnot. So you've seen my example before that I specified an AMI ID as a parameter. I could have used that as a map as well. Use that because you don't want to hard code those things. So you can you don't want to have a single use CloudFormation template for just one thing. You can kind of make them a bit more reusable with parameters and mappings. And you can also use Secrets Manager and Parameter Store to store those parameters. So, for example, if you have a CloudFormation template that uses a username or something like that, or an AMI ID, you can store that in a parameter store and invoke it during creation. Parameter Store is actually a service from AWS where you, guess what, you store parameters, right? So, and also, one important thing, do not hard code secret stuff in templates. Anything you don't want to be put online or a repository or anything, do not hard code passwords or secret keys into templates. You don't want to do that. It's horrible. There's Secrets Manager, there's Parameter Store, you can do that. And for example, in this example you see here, it's a database, it's an RDS database that's actually resolving a password for the master user from parameter store directly from the template. So that parameter or that password is never exposed. Only it's present in the template like this. So this is really cool. Okay, I think we can move on to CloudFormation's little younger brother, and that is a favorite of everyone's, including myself, and that's CDK. CDK stands for AWS Cloud Development Kit. So it's a lovely little framework that also allows you to write your infrastructure as code, but with a bit more a flair to it, and I'll explain that in a second. So why would you use CDK? Well, maybe you don't like JSON. Maybe you're a human person and you can't read JSON. It's horrible. Maybe YAML ain't your thing, right? You don't like those tab spaces, and we all write a YAML file, then there's a bunch of tab space offsets that kind of break things, and it's not the best things. And I wouldn't call these things languages properly. It's not like JSON and YAML are technically markup languages or object notations, but there's better ways to do it. Maybe you know a programming language. Maybe you are good in Python or Java or some other language. Well, actually, CDK allows you that. So CDK is basically a general purpose framework, a multi-language development framework for modeling your infrastructure as code. So you can use languages that are defined here, such as Python, JavaScript with TypeScript. You have Java, you have C#, and actually there is F# as well, but it's not present on the slide. So if you are good in any of these languages, you can use these languages to write your infrastructure as code on AWS. Now, it's not just a matter of, hey, you have an SDK and you can just create resources with that. This actually is an interaction model between your JavaScript code or your TypeScript code and CloudFormation, and I'll get to that in a minute. It kind of handles all of those things for you. It's much more streamlined than you just coding your stuff with an SDK, which you can absolutely do. So but this is much better. So a story of mine, when I joined AWS, I didn't like CloudFormation. It was very complex with the JSON thing, and I didn't enjoy it. So I built my own Python application to create EC2 instances for me. I wrote it in Python using the AWS SDK, and I would just create an instance, and I could do termination of those instances. That's great, but I would have to handle all of it. I have to track all the instances. Are they still there? If I want to delete an instance, I would have to specify specific functions to do those things. Horrible. Now I can do it with this. I can do it much more easier with CDK, and it allows me to do this through my language of choice. Just want to talk about one of our customers, because it's very important to mention customers when we talk about CDK or any infrastructure as code tooling. Alma Media is a customer from Finland, and they are basically a media company. It's a multi-channel media company present over in Finland. It employs over 2,300 people. They cover 80% of the Finnish population. They have over 100 websites and apps, and they use a lot of serverless. Now, when I talk about serverless, they have a very complex serverless setup. They have over 2 billion with a B, so billion Lambda invocations per month. Actually 2.061 billion Lambda invocations per month, which is quite a lot, right? So they're focused on serverless quite a bunch. And when it comes to complexity of their setup, they have over 100 AWS accounts. So what they wanted to do is kind of use the in-house knowledge to build serverless applications through infrastructure as code. Now, CloudFormation can do that for you, but CDK does it a bit better, or it's a bit more streamlined when it comes to serverless. So, and Alma Media has been using CloudFormation, and they have also been using Terraform, but they want to, kind of a better framework that helps them handle Lambda functions. So they have opted into using CDK for all of their serverless projects, right? So they actually write it in TypeScript, and in essence, it has actually improve their developer experience. And when I say developer, I mean the people developing their infrastructure. And what do we want most in the world? We want to keep developers happy. So give them a better experience, help them build their building blocks. So Alma Media's developers actually are able to build building blocks, which can they develop new additional parts of their infrastructure. So, and I'll get to that in a moment. And, if they've implemented also like all the best practices when it comes to infrastructure as code. So they have static code analysis. They have automated tests. They have some version dependencies from their private package registry, and it's much more easier to define their infrastructure through code right now in multiple different environments because they have access to like dynamic feature, blah 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 blah, those kind of things. So pretty cool, and they're planning actually to even more further spread out those building blocks across the company, and they want to also create those building blocks in different languages such as Python and Java, because this enables a lot of other people who are maybe more proficient in those languages to contribute. So let's talk a bit more about CDK. From construct to the cloud. So how does CDK work? So CDK basically, you create these things called constructs. This is the source code. This is the meat and potatoes. This is what you actually create to provision your infrastructure, right? Then you use the AWS CDK CLI. So there's a CDK CLI tool that actually is the brunt or is the core of CDK that takes the constructs you have written and converts it to CloudFormation. So it actually generates CloudFormation in the end, and it passes it on all to CloudFormation to handle all the provisioning and updates and all those things. And this is important because why would you offload those things to your own service? Why would you create your own specific framework or whatnot to do this when there's something already existing like that on CloudFormation to do that? So, and you'll see that later on. So, kind of the main concepts of CDK is the core framework. It's the thing where you write your code, where you create resources and stacks and apps. So you can have multiple apps. A single app can have multiple stacks, and a single stack can have multiple resources, right? So it's kind of that branching tree structure. There's a construct library. So construct libraries are kind of a opinionated way of creating specific resources. Unlike CloudFormation, we kind of come to you with some sensible defaults, and we also come to you with entire solutions. And I'll get to that in a minute. And finally, the CDK CLI, the tool that actually ties all of this together and it makes it work and helps you provision all of these things through CloudFormation. Okay, let's talk about CDK constructs. So there's a couple of different types of constructs on CDK, and I want to mention all of them because usually people kind of skim through them, or just basically most people who use CDK, at least in the beginning, just use AWS services constructs. But I want to mention all of these things. So there's CloudFormation. CloudFormation construct is basically all of the resources in specification. Anything CloudFormation can create, you can do it through CloudFormation. There's AWS services. This is, as I said, a kind of a higher level abstractions with sensible defaults. And finally, the design patterns. Now, the design patterns are, think of it as a solution or a more complete thing. Like you see this piece of code here, it creates an application load balanced Fargate service. So it will create an application load balanced Fargate service on AWS with 3 lines of code. So it does a lot more things. So you define one thing, and what this thing does actually, it generates 817 lines of CloudFormation code. It generates all of these different types of services, and you basically, at the end of the day, you get an application load balanced Fargate service running on AWS ECS. So pretty cool. So this is a very super simple example how to get started with a construct or a bit more complex setup just by using 3 lines of code. So, but let's actually show you how these things look. So this is an example of a CloudFormation construct. I'm creating a VPC by using the CloudFormation construct. Now, this is the vanilla CloudFormation construct. Everything that exists in CloudFormation can be created through this. And you see here that I'm creating a new VPC, defining a CIDR block for it. And once I create this through CDK, I will just get a VPC, nothing else. Because I've just told it, hey, create me a VPC, and that's it. But if I want a bit more, if I want the sensible default thing or the service construct, I can just do this, this is calling a VPC. I'm creating a VPC through this. Very similar, also defining a CIDR range, nothing else. But unlike the previous example where it just creates a VPC, here it will create a VPC, elastic IP, it will create internet gateways, it will do a lot of more different things kind of to give me some more default values, which makes sense when you create these things. Again, you have the freedom to change all of these. These are not mandatory, but these are some defaults that come with it, and this is how most people get started. And last but not least, the same thing I showed you a little before, the ECS application load balanced Fargate service pattern, it's a pattern, right? So here I have a bit more lines of code, but I have defined like a memory limit, CPU, and I have defined which task will it execute. These things will create a lot more things, and you will see here it has 39 things it has created, or 39 messages when it comes to creating. So it creates all of ECS services, load balancers, listeners, VPCs. It does all of that for you just with those couple of lines of code. But with all that code, there's a lot of problems, right? So how do we prevent those mistakes? How do you prevent mistakes in your code? And especially when it comes to CDK, CDK is a bit more, it's an actual programming language. It uses programming languages in the backend. So there must be some better ways to avoid the code, because there are some better ways to make those mistakes, right? So how can we avoid those mistakes in a bit better way on CDK? Well, luckily CDK has this testing framework on CDK, or available to CDK if you write CDK in TypeScript. So we can use things such as Jest to write tests and, test our infrastructure code. But before I get into that, there's like 3 types of testing we can do on CDK. When it comes to TypeScript, we can do snapshot tests. By using Jest, we can actually create snapshots of our current setup and test it against that. We can do fine-grained assertions, where we can define some assertions, we can set some expectations of, hey, we wish that our infrastructure looks like this or that. And last but not least, we can do validation tests. Now, validation tests are nothing CDK specific, they're generic programming tests. So I will not get too deep into them, but think of it as this way. So instead of using some specific framework or some testing platform for this, you can just define validation tests within your code. For example, you want to define some time period for your SNS dead letter queue. Yes, that's it. So, and you want that period to be between 7 and 15 days. Now you can write a whole test for that, or you can have a validation within your code that says if this value is out of this range, just fail the execution. So it's the fastest way to fail, to get your mistakes out already. So. And this is kind of boils down to the test-driven development, where you write your tests, where you write your validations before you write your actual logic. So, and I'll cover snapshots, tests, and fine-grained assertions today in this talk. So let's talk about snapshots. Let's show me them snapshots, right? What are snapshots? So here's an example. This is a test from CDK test file, basically. In this CDK, how would you call it? The CDK app or this stack creates an SNS dead letter queue, right? Simple notification service dead letter queue. So, and this test actually says, hey, I want to match my snapshot. Any changes to my code need to match my snapshot. And how do you get that snapshot? Well, the first time you write your test, or the first time you execute your CDK code, once you do all that, it actually generates that snapshot from the current setup. So if I create specific resources, then run a test, without a snapshot present, it will generate the snapshot. Then every other time I run the test again, it needs to match that snapshot. So it's a great way to kind of avoid some problems directly from here. So it's not very flexible, but it's a quick way to get started. So here's an example how the snapshot looks. So it looks very much similar to a CloudFormation template. It just has some additional extras. Again, it uses Jest for this. And this snapshot actually sits in the tests directory under __snapshots_ directory. And one of the things you need to do is, if you are moving this code through a pipeline, which I hope you should, I hope you are, you need to move the snapshot as well if you want to test this in a pipeline. So make sure to commit the snapshot tests, or the snapshots as well with your tests. Otherwise, every other one will pass. So, like for example, I have made a change to my template here, and I have run npm test again, and it will fail because my newly changed code does not match the snapshot which already exists. Now, if I want to overwrite this, I can just use the npm test -u command, which will overwrite the current snapshot to the latest state, right? But again, I said this is great, but it's not so flexible. It's very rigid when it comes to things we can test. We can only do snapshots. But what about we approach this in a bit more controlled way? Especially, let's approach it like proper test-driven development, right? Let's define specific test states or test cases or expectations before we write your code. So this is where fine-grained assertions come into play. So here's an example. The same stack, everything same, no more snapshot tests, but I am actually defining that my stack has the following resources. It needs to have a CloudWatch alarm with this specific, configuration, such as a metric name and namespace and dimensions. So my test immediately expects that this is available, that this will be present, and if it's not, my stack will fail. Right? Another example here is I expect that my stack has a specific configuration on my SQS queue. So it needs to have the message retention period, the thing I told you about, the 7 versus 15 days, has to be set to this number, right? And if I run my test and those things are not set into such a way, or they do not meet those expectations, my test will fail. So this is a really, really great way to kind of define things before you code them. Then you can fail quite fast if they are not met. You can ensure that you run proper test-driven development even on infrastructure code development. Okay, I want to step back to our lovely friend CloudFormation. I want to talk about a feature of CloudFormation that has been released last year, I believe late last year, and that's CloudFormation Registry. Sip of coffee there. So let's talk about CloudFormation Registry. Why is that important? Why is this a really cool feature? So you may be using resources outside of AWS. A lot of people do, right? So not everything sits on AWS. We have people running hybrid stuff. We have people running their online business applications. Maybe you want to deploy a GitHub repository. Maybe you want to create a Datadog dashboard. Maybe you have your line of business application that creates unicorns, right? How can we create a unicorn when we deploy our infrastructure? Let's say our infrastructure requires a unicorn, right? How can we do that through CloudFormation? Well, CloudFormation Registry, it's basically an open approach to managing external resources. So before CloudFormation Registry existed, you could technically create external resources by kind of stringing up a Lambda function here and there by basically running a Lambda function as a custom resource, and that would invoke some API call or something like that. It worked. It was a bit clunky because you have to make all of these backwards calls, and you depended on Lambda functions. And every template you write had to have those things. So now with CloudFormation Registry, basically you can create a provider, you can create a custom resource that sits within your AWS account, and it can be invoked natively through CloudFormation like you would create any other resource. Like right now in CloudFormation, you want to create an EC2 instance. It's AWS ::EC2 : instance, and then you define all the properties. But let's say I want to create a unicorn, so I can do Darko : unicorn : factory, and just unicorn properties, and it will create my unicorn. Imagine if we can do that. Well, you can, right? So it's great. So it has its own CLI. It's all open source. It's all available on GitHub, and you will actually see me use it here later on. So why is this great? I mean, besides you creating your own unicorn factory locally, that's fine. But one of the things we see here is that we have a lot of third-party partners, such as, again, Datadog, Spotinst, Fortinet, and a bunch of others, already create their CloudFormation resources available, right? So one of the things you can do, you can kind of take their custom resources, import them into your AWS account, and use them from there if you want to create some third-party resources straight from AWS. And this is really great way, especially if you're like an ISV, if you have a product that kind of relies on AWS, you want to launch it from CloudFormation, you want to give your product CloudFormation support, you can do it right now. So how does this actually work? What do we need? So we need a couple of things. We need CLI tools. We need plugins. Currently, there are 3 types of plugins available for CloudFormation Registry. There's the Java plugin, there's the Golang plugin, and there's a Python plugin, which is currently, I believe, in beta. So I don't think the Python plugin is yet available in GA. This means that when you write your template, when you write your resource, you need to write it in one of these 3 languages, into Golang, Java, or Python. And I'll show you how it actually looks in the demo later on. So all of these things are generally available. You can get them from GitHub using pip or whatnot. So it's pretty easy to get started. Now, once you get started with this, you need to model your resource. One of the first things you need to define is like, what's your resource name? What properties does it take? So here's an example of my unicorn factory. It takes things such as like a superpower, it takes a unicorn name, it takes a unicorn family, whatnot, right? So all of these things are defined. And it's kind of in the CloudFormation registry schema file within the directory structure, and I'll show you how that looks later on. Because you have a command line utility, there's a new CloudFormation CLI tool that generates all these things for you, so you don't have to generate it manually. And you can define some handlers, like what kind of handler permissions you require, because what are handlers? The create, the update, the read, the delete, and the list. Handlers are the things that actually make changes or make actions against your third-party resource out there. And finally, those handlers are the meat and potatoes, or the brunt of your CloudFormation registry or custom resources, where you actually write the business logic. So this example you see right here is creating a unicorn in Golang. So it's basically just making an API call to an API endpoint somewhere out there, and it will create a unicorn by just running an API call. Like, this is the create handler. The update handler will update that the same API endpoint, and the delete will delete all the things. But also, like any other things, there are tests. So it's not just a matter of writing your code and hope it works. There are tests built into this to kind of help you validate that it works out of the box. So by the power of SAM local, and I didn't talk about SAM or the serverless application model today for some reason, but SAM local gives you the ability to locally test, does this work? So it will, in essence, emulate locally CloudFormation endpoints that will make requests to your API or whatever your third-party endpoint resource is. It will make it locally, and you can run through the command line. It will, in essence, run the create handler or whichever handler you're trying to invoke, and it will do all of those things. And now, once all of that is tested, you can upload by using, again, the mentioned CFN CloudFormation command line utility. You can just submit the new resource. It will basically create all the required things such as metadata, permissions, whatnot, for that thing to exist in CloudFormation, and it will register that thing in CloudFormation, and you will be able to see it on your resource types on the CloudFormation dashboard. And actually, instead of me going through all of these things, all of these slides, let me actually show you how this works. I can just come here and flip to my command line utility. So one of the things I have here, if I just make this full screen and then just clear and then LL. So right now I have that same unicorn factory set up here, and the schema here, if you want to have a look here, if I go Darko unicorn factory, this is the schema. So the schema is I define my type name. So this is that Darko : unicorn : factory. The description, the properties. I want to define a name. I want to define a superpower for my unicorn, some family. I want to say which properties are required for my unicorn, which properties are read-only, what's the primary identifier, and what kind of permissions each handler requires. In this case, because I'm just creating a third-party resource on some API endpoint, I require no permissions in this case. And now the important thing is the CMD resource goal file. Now this is in Golang. If I would be doing this in Java, I would write this in Java. If I were doing it in Python, I would do it in Python. I have a Golang example, and you can actually see this somewhere on my GitHub repository. I don't have a link anywhere here, but if you search my name on GitHub, you will find my unicorn maker repository or something like that. You will be able to see it there. So if I show you how this looks, here's the important thing. Here are the handlers. Here's the create handler. Again, I showed you this before, but in essence, it just makes an API call to an endpoint with some data, right? So it passes like the request body or the parameters it has to the endpoint, and those things are basically being created. Here's the read handler, and you get the idea. So this is where you can go crazy here. There are some things you need to kind of follow along, how to handle callbacks to CloudFormation, but in essence, it's business logic that you can do whatever you want, right? It's really up to you. How will you implement this? So once I have done this, I can just do make build, because this is Golang, so it needs to be compiled. So if I do make build, it runs cfn generate. So cfn generate is the CloudFormation command line utility. It generates some files that it needs, and it builds. It basically makes a binary. Now, test part, I can do SAM local invoke test entry point. Yeah. So let me show you the test. So there's a file in SAM tests called create.json. And this is basically running a create call to my endpoint, and that's it. So it will pass on these parameters. These are some credentials that don't work because it's not actually running it on CloudFormation. It's just running it locally. And it will run SAM locally. So if I do SAM local invoke test entry point and pass it on that create JSON event like so, it will invoke local Lambda function, basically a container image that emulates Lambda and CloudFormation. And we can see that there's a success, create complete, and it has actually created this thing on my endpoint. If I go here I'm actually using CRUD for my API endpoint. If I refresh this, I will see that I have a new unicorn here. If I go here and just zoom in, I can see that there is a unicorn created. So I am certain that this works now. Once this is done, I can go here and do cfn submit -v and then define the region. If I do this, it will package my project. It will make sure that I have all the things I need on AWS to kind of, with all the role permissions, all the things I would require on AWS, and it's basically running a registration now. Now it takes a minute or so to kind of register this, so I will not wait for this. Like any good cooking show, I have it already prepared. And one of the things you can see here, if you go here on the cloud resources types and refresh this, go to private, you will see that I have my unicorn factory with my schema and all of these things here. So in essence, you can also point it to documentation, to all of those things here. Like it's really, really cool. You can have version control, have multiple different versions of the same file, of the same resource. And now if I want to use it, I can literally just take Darko Unicorn Factory in my CloudFormation template within this AWS account, within this region, and just use it as any other CloudFormation resource, just like that. Pretty cool, pretty flexible. And it gives you the ability to have a much more simple way to deploy custom resources. B, if you own a product that people might want to deploy through CloudFormation, it makes it more easier for those people to use your product like so. Okay, back to slides, and let's wrap it up. Wrap it up with a couple of takeaways. And this is important. So I want you to take 3 things away from this today. Number 1, best practices start with the editor. Use proper tools and plugins. Use the proper tooling to help you write your infrastructure as code. be sure to do it, right? Treat your infrastructure as any other code. So take it through the pipelines, take it through testing. Do not treat CloudFormation or CDK or Terraform, whatever you use, do not treat it as just something very specific. It's also code. You should test against it. You should have people look at it, peer reviews, all those fancy things. And last but not least, use testing tools no matter which framework you're using. And I believe that all the frameworks out there have testing utilities. Use them. Use things in Terraform. Use CloudFormation. Use Taskcat. Use Jest in CDK. Doesn't matter what you use. Make sure to use testing tools, because you don't want to fail once you're already trying to deploy to production. You want to make sure you fail within the first stage of the pipeline or within your own editor. Well, that has been me. That has been my talk. I really hope you enjoyed this. I guess we can have some time for questions right now. I'm not sure, Sergey, have there been any questions, or are people... I guess we can start answering.
Can you hear me?
Yes, I can.
Thank you. Thank you for this talk. I have a few questions, actually. It's a nice talk. I learned something new. Even I spent last week on doing CloudFormation CDK. I learned a few new tools. Thank you.
You're welcome.
I don't like to write YAMLs and JSONs, and I heard the news that there is a new version of CDK for Kubernetes. Did you hear about it?
Yes, there is. It has a weird name. It's a cloud development kit for Kubernetes. So I've heard about it, but I have not played around with it. So, but again, it gives you the ability to, instead of writing all of those Kubernetes configuration, all the YAML configuration, you can actually use the same approach like you would do on CDK to write those things. So it's kind of an abstraction layer above JSON or YAML to help you do more things. And think of it this way. So it's not just easier to write, but it also allows you to think things such as read off disks or loop or make conditionals, all those things. So it's basically the same thing, but just for Kubernetes configurations.
Yeah, I think it's worth to mention it. And you said that you will not compare different technologies, but can you help to our listeners to choose what to use? Because, for example, if I need to create infrastructure as a code and have a Lambda on AWS, for example, I can choose CloudFormation, I can choose CDK, I can choose Amplify, for example, or SAM, serverless application model. How to choose technology?
So if you use serverless, do not use vanilla CloudFormation. It's a pain. So that's why we created SAM. SAM is a serverless application model. And I didn't talk about it today, but SAM basically gives you the ability to create everything CloudFormation can, but it's easier to do with serverless, right? Because it has transformations to for serverless applications. So it's easier to create a function, DynamoDB. So think of it as this way. It takes you 20 lines of code to create a fully fledged serverless application with the DynamoDB table, API gateway, and a Lambda function and permissions with SAM. So my answer to your question is, take a look at what you're trying to achieve and try to get a tool that will give you the most flexibility with it, whilst giving you while not forcing you to spend a lot of time on it, right? So if you're excellent in Python, do not try to learn CloudFormation or SAM, use CDK. That should be fine, right? So try to use the skills you have and what you feel like you're using and build on top of that. So my only advice is, no matter which tool you're using, you should just use it. Do not avoid infrastructure as code.
So they are equally good, but I need to choose something that I know. If I know
exactly, I mean,
Python.
Yeah. So
okay.
And the thing is, it's relatively easy to kind of flip back and forth, especially when it comes to AWS, and especially when it comes to SAM and CloudFormation are basically identical. So besides, think of it as CloudFormation on steroids on serverless steroids. So you can do more serverless, or you can do serverless easier on SAM, but you can do everything else the exact same way.
Okay, but what about Terraform, for example? Should I use it, or should I use CDK or CloudFormation? How to choose?
Yes. So yes, absolutely. I mean, so Terraform is amazing. I love Terraform. I love Terraform syntax, the HCL HashiCorp language, or so how they call it. Yeah, it's beautiful. I love the way Terraform is structured. Terraform is one of the first ISC tools I've started using, and I cannot say people not to use Terraform at all, because I think it's great. So really comes to that thing. Do you feel that it can fulfill your needs, your requirements? Does it support all the resources you need to create, or you plan to create? And do you feel comfortable writing it, right? Nothing is worse than having to write some bad code in a language you hate. It's good to write bad code in a language you love. So that's why you should, maybe, if you like Terraform, absolutely use it. Again, there's slight differences when it comes to CloudFormation and Terraform. One of the things I like to point out in CloudFormation's favor is keeping the track of the state of, or actually the state of the of your resources on Terraform is a bit more specific. You need to define a state file. You need to either write it on CloudFormation on S3 bucket, then you have to use a DynamoDB table for a lot of different things. So that's kind of where some incompatibility comes in, or at least my problem with Terraform is that, especially if you have multiple people writing the same things. So yeah, but yes.
Okay, we have next question from the chat. I think you can read it. It's about yeah.
I'll read it. It's from Kirill. Kirill says, how and where CDK code is converted to Cloud Assembly CloudFormation? For example, could you use Kotlin instead of Java? The same question about external resource providers. So it's actually being done through the CLI, Kirill. I'm not sure if you can use Kotlin just out of the box, because it uses a specific module, I believe. And the thing is, it's open source. So if you have the time and the will to create your own kind of a interpreter for this in Java or Kotlin, sorry, you can. Right? It's open source for exactly that same reason. So we do expect more languages and more things to come in, but it's actually part of the CLI. So. And another question from Alexei. So CloudFormation looks like a highly optimized infrastructure as code system. Probably it's a natural order of things. Yet best practices and design patterns you were talking about seem generic. Do you think we will get a good ISC framework which supports hybrid clouds? If yes, what do you think the key features, capabilities of such framework? Okay, multi-cloud ISC. Well, one of the multi-cloud ISCs you have is Terraform. Terraform does things great. But the problem with multi-cloud, problem with multi-cloud infrastructure as code is multi-cloud itself. Every time you do multi-cloud, you need to kind of boil down to the lowest common denominator, and this is where the similarities are beginning and they stop, right? So deploying an EC2 instance, or if you want to deploy an instance on cloud provider A and B, might be completely different. So having a generic ISC tool that can basically do the same thing with the exact same piece of code on multiple cloud providers is a big abstraction. So it would require a lot of effort to do. So I mean, I'm all for that, right? So if you think that you want to use multi-cloud, if that suits your needs, right? There are tools out there. Like I believe Pulumi does that. Pulumi supports multi-cloud. Terraform does that as well. So there are tools out there. CloudFormation is built for AWS, but with the CloudFormation registry thing that I showed you, you can actually create Azure resources with CloudFormation registry if you want now. So it's really up to you. As long as you code it, it's perfectly possible to do that as well.
Yeah, interesting. I have the same opinion, because all the technologies that try to do something for multi-clouds, they're just common denominators, and they don't support everything. That's the issue.
We have the same thing.
Yeah. Can you say a few words about will CDK replace CloudFormation in the future, or they will be developed in parallel?
Well, I don't see them being developed. I don't see them being replaced, because for CDK depends on CloudFormation. So CDK is basically just it's CloudFormation's younger brother, so it uses CloudFormation to do all of its things. And there's different use cases. So when it comes to pure CloudFormation, you have, let's say, a bit more finer control of how you create things, and it's a bit less. So CDK in itself is is a programming language. You kind of throw the dice and see what happens. While in CloudFormation, you exactly see what's going to be created, and you define each step more or less. You have a slightly more bigger control in CloudFormation than on CDK, and that's the reason I feel that there are different use cases for both, and people are using them interchangeably. So I see. I mean, I cannot confirm or deny, but I don't see a reason. I don't see it happening anytime soon.
Yeah, okay. So is CloudFormation more like an assembly language? It was a question, yeah. And CDK is more high-level language because people look at these technologies like a low-level and high-level stuff.
Yeah, I mean it's fair to say that to an extent, but at the same time, CDK can also do very much low-level stuff like CloudFormation. I've shown you like the CloudFormation constructs, which basically do the same thing. So you can use CDK to create low-level CloudFormation resources. So the non-default ones, right?
Yeah, and I think the last question, you mentioned that there are tools that help to find resources that are available in one region and are not available in different region. Are region different? How to choose the region where we should deploy our infrastructure?
So the first requirement is absolutely geography and speed of light. So depending on which one, where you need to host your stuff, where is your customer base, and secondly, when it comes to region and service availability, what we're trying to do is we want to make sure that all the regions have region availability parity, so that all services, all features are available across all the region. That's not the case all the time. So you want to make sure that the service and the feature you want is currently available within your region. Now, CloudFormation can check those things for you, right? While trying to execute using CFN, what did they use? CFN lint, yes, CFN lint can check that for you. But there's also better ways to do those checks. You can actually use AWS CLI to check if a specific service is available in specific region, or in which regions is service A available. And now, how to choose a region? Again, speed of light. Where are your customers? And do you need all of those resources, all of those services? Or if a service that doesn't exist in that region, can you use it from a different region? So that's kind of my answer to that question.
Is it possible to have resources in CloudFormation that are deployed in different regions?
Absolutely. It's a feature called Stacksets. Stacksets actually can deploy across multiple regions and even multiple accounts. So. Yeah, so
that's nice feature.
Use multiple regions and use multiple accounts. Absolutely.
Is it a best practice to use multiple accounts?
Yes. That's absolutely. So no, don't use a single account. Don't be that person that has one account to rule them all. Make sure your production account should just be your production account. Nobody should have access to a production account. Nothing should ever happen in the production account besides production. You want to play with things, have your own account. In an ideal scenario, every developer, every architect should have their own account to play around with, to test things out, to have the first initial development stage of a change sitting in their own account, and then things go on from there. Absolutely. Not to talk about logging and security accounts and all those things that are mandatory.
Yeah, security is mandatory. That's true.
Absolutely.
Okay, I think I don't have any other questions. We can move to Zoom chat.
Yes, let's move to Zoom chat.
Yes, and discuss something there.
Yeah, I'll join the Zoom chat. Thank you, Sergey. Thank you all. Thank you very much for attending my talk. And let's, if you want to talk, over in Zoom.
Thank you, Darko. Thank you, Sergey. In fact, first of all, thanks for answering my another question. And since I cannot get into the Zoom chat, unfortunately, can I get my last question?
Yes, you can.
Here.
You just did. I'm sorry.
Yeah, thank you very much. Thing is that actually I was listening very with great interest. What I'm doing in Dell Technologies, actually, I'm doing doing internal cloud with quite a few features which provided to our own internal engineering customers. And interesting thing is that we are kind of having responsibility for both providing programmatical way to the people and engineering teams, as well as our colleagues are in the same team, essentially, are also responsible for all the tracking and stacking you were talking at the very beginning, because there is no magic in this world. And if someone just sees YAML, it means that there are still a lot of people running in the lab. So what do you think about it? And this is more philosophical question. Where is the magic? I mean, are there dozens or hundreds of thousands of lab people racking and stacking things, or is it something interesting that can help it?
I would say there are definitely people who are still racking and stacking things. I don't think we have invented a way to kind of magically poof servers into existence. But here's the thing, like those people are just doing that. Those people are specialized for racking and stacking and they do it at scale. So you can provision your own servers at scale. So it's kind of like it's like in the old days where you would have separation of duties. Not everybody was doing everything. You would have specializations, so we can be more efficient. So this is the same thing. We have people and teams and companies and whatnots who are specialized in racking and stacking. So you, an engineer, can be super specialized in provisioning amazing infrastructure through YAML or JSON. So I think that's where we are going, and that's kind of that's kind of where it goes.
So there is no silver bullet, but maybe someday we will get not just DevOps, but DevOps, Sec, Lab all together.
Most likely, we'll have a big old acronym, right?
Yeah, maybe some days. No, I'm looking forward to see it another day. So thank you once again. Спасибо, Darko, спасибо, Сергей. И я призываю даже всех перейти в Zoom-чат для того, чтобы позадавать больше вопросов Darko. Спасибо.
Спасибо.
Спасибо.